In this video, we're going to explore similar triangles and what makes one thing similar to another. The basic definition is that things are said to be similar if they have the same shape but different size, so if they have been enlarged or reduced. The mathematical convention of writing similar is with the three vertical lines, or you can use the little squiggly single line to show similarity. To test for similarity, we have tests very similar to what we had with our congruence tests. Let's have a look. If we've got two triangles, we would say that they're similar, so this one is just a larger version of that one, if corresponding sides are in the same ratio or proportion. And the way that you check for this one, remember to look for your scale factor, you put the image over the original side. So I've got the 2 and the 1, they're corresponding sides. If these two things are similar, that ratio should be equal to the ratio between all of the other sides. So let's have a look. 5 and 2.5. That should be equal to the same value as 2 over 1. We should also have the third side being in the same ratio, so the 6 and the 3. Is that equal to the ratio between all of the other sides? So 2 over 1, that's 2. 5 divided by 2.5 is 2. 6 over 3 is also 2. So all of our corresponding sides are in the same ratio, so we have similarity. And this similarity is known as side, 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 or SSS. Our second similarity test is if we've got two pairs of corresponding sides in the same ratio and the included angle. So the angle must be in between the two sides that we know about. So first of all, let's just check that our sides are in the same ratio. So we will check, is 4 over 2, so 4 over 2, is that the same as 2 over 1? 4 over 2 equals 2, 2 over 1 equals 2, so we have our sides in the same ratio. The angle here is denoted by the same symbol. We've got a little filled in dot there, so we have our angle being the same. So we can say that we have similar triangles, and we have a side, an angle, and a side, SAS. Our third check for similarity is if all of the angles are equal. So just when you're drawing your triangles, if they're not already drawn in the same orientation, then you need to do that. So just make sure that your dots that are the same are in the same position. So I've got a solid dot there, I've got a cross here, that matches that cross there, and I've got an open circle here, open circle there. They're all the same, so our similarity test is true, and we've got an angle, angle, angle test. Remember also that even if you only know two pairs of corresponding angles being equal, then it's impossible for that third one not to also be equal, otherwise your triangle wouldn't join up. So it's enough just to find two pairs of corresponding angles, and then by default your third one will match as well. The final similarity test is our RHS, which is the right angle, hypotenuse, and another side. So if ever you have a right angled triangle, you'd be looking to use this similarity test. So both of my triangles have a right angle. Then I'm checking, do the corresponding sides have the same ratio? So let's check. The image over the original, image over the original, they both equal 2, so both pairs of sides are in the same ratio. We have a right angle, so our similarity test has been proven, and that's an RHS test.